Oops. Hello guys. Today we're gonna create a lead screw mechanism, which is a linear actuator that could help you a lot while building your robot. Like for example, to move the extruder from one place to another, or also to the extruder mechanism to get out the mix outside the tank. So let's start. First, you click here, File, New, and Part. So for the first step, let's create a nut. So we go to Sketch. Sketch, we choose alzado or front plane. Alzado, sorry. Oh, okay, click alzado, we click Sketch. Okay, there we are. So now we start by clicking here in Polygon. We choose 6 sides and we create an hexagon. We click Smart Dimension, and here the measurements we click 22 millimeters. So now to fully define it, we click this and we select horizontal so it can't rotate. So now we click Features, Extrude, and we extrude 7 millimeters. Quickly OK. Okay, click spacebar, and we're going to draw here a circle. Click here, Smart Dimension. I'm doing this quickly because I know you already know this, how to do this. So you click here 16. Now you go to Features, Extruded Cut, and you click here through all the material, and you click OK. Now we have our bolt. For now, we don't need to create a pattern. You will see why. For now, this is just fine. So save it, please. You can save it as nut. Okay. Now you open a new file, new part. Now go to Alzado, click Sketch, and then you create a circle at the center, then Smart Dimension, and you click here 16. Right now we're building the lead screw. Okay. So now that you have this circle, we click Extrude Boss, and we click this arrow to reverse the extrusion, and we select 300 millimeters or 30 centimeters. Okay, and we click OK. Okay, that's where our nut will like move around. Okay, now you go to this face and you create a drawing here. Click Sketch. Now you select this edge. I'll just move around so you can see it. Oops. Okay. You select this edge, then you click Convert Entities, and now now you have it in this sketch you are doing. Okay. Now you select this line you just created, and then you go to Features. Then you go to Curves here at this part. You click this arrow, and you click Helix and Spiral. So here it was already selected, but yours will not appear like that. So in this case, you need to select like this one, 4 millimeters in the pitch, this side. The pitch is the distance of each turn of this screw. So you need to put here 4. You will also need to check this one because originally it's like from the other side. So please check this box. Then you select 90 degrees angle to the start, and then you choose the revolutions. Since the length of the screw is 300 and we have a pitch of 4, if you divide 300 over 4 millimeters, it will tell you that you need 75 turns to complete the whole screw, because each turn is 4 millimeters because we specified here. Okay, so once you have these 4 things modified, you click OK, and then you have this drawing here, like over the cylinder you just drew. Okay, now you move to another plane. You choose this type of plane, like that is cutting the cylinder like this. You select this, and you select sketch, and then you move over here. You can click normal too. Okay, now you start from here. If you rotate, you'll see it's started right here, but it's actually starting from the other side, but it's fine. It doesn't matter. So let's just start like here and get closer. Now you're going to draw in this sketch. So you're already in the sketch, as you can see from the arrows. So now you need to draw a circle here at this point when you see this orange circle. You start drawing, and from this one you select a dimension of 2.5 millimeters. Okay, now you exit the sketch. Remember, exit the sketch, and now you click features and in swept cut, the one right here, swept cut. Then at this part, what swept cut does is that you select like a shape, an initial shape, and then you select a path from this shape. What this shape, in this case a circle, should follow. No, so in this case it's an ellipse. So we are basically telling SolidWorks, okay, this circle that will cut this material will follow this ellipse path. Okay, so first in this part we select the circle, and in this part we select the path. You see here, path. So we select this. It takes a while to simulate it, and then you click OK. It will take a while to complete. Now you have made a screw where the bolt will move around. Okay, here, length of 30 centimeters. You click File and Save. Put it screw and save it. Now you need to open a new assembly. And we're gonna put together the 2 pieces we created. As you can see, if both of the pieces are still like hidden here in the window, you will see it at the left side. So you can basically just grab it and put it here. Boom. Okay, now you have in the assembly the screw. It's kind of slow. Too many details. You have right here. Insert another component, and this time you select the nut. Okay. Here it is. Okay, now you have the nut, and you want to place it here, concentric to this screw. So let's select this face. It's kind of slow. Okay, I'm gonna select this face, the outer face. We click Mate. And you select this face. And you click OK. Okay. Now the screw, well, sorry, the nut will move all around this. I will just close this because the computer is so slow. Okay. Hopefully it's better. No, a little bit. Okay, now we have this. And as you can see, I just click OK. This thing can rotate through this. The problem with this is that we can't rotate this screw because it was like the first piece we put, and as you can see, it's fixed. So right now we're gonna just click right click, and we will put float. So we unfix it. So now you click save. This is like the first part. So we can put it just assembly. Okay, so now we can build a support where this screw will be. So now we click File, New, and New Part. So let's build us a support, and so we click Saddle, and we click Sketch on this side. Click a rectangle, and you put some dimensions. You can click. You can put 120 units, and you put here 40. Okay. Now you extrude it. You can choose 10 millimeters. Would be just fine. And right now, come to this face, and we're gonna draw some sketch, and we're gonna draw a circle for our screw. Now we put this, and we choose 16, the same diameter as the screw, and click Features, Extruded Cut, and we choose Through All, and we click OK. Good. Now we can do something else too. Instead of fillet, you can click the arrow and choose chamfer, and start doing some chamfer here. So it's a little bit different from the other ones I've done in the previous courses. So we click OK. And now we have our support. We click File, Save, and put Support. Okay. Let's go back to our assembly. And we should add another component, and we add the support right here. Oops. Okay. Now we want to center this face with this face using concentric. So we're gonna select again this face. You click mate, and you click this face. Now it's centered. It's concentric. You click OK. Now you want to bring this back, so you can click this face and this face, and we don't want it coincident, so we can see some part of the screw. So let's just put this distance. Let's select 10 millimeters. Okay, and we click OK. Good. Now we want another support from this side. So what we can do, instead of just inserting another one, we can just push the control key and grab this. And you see, it duplicates it. Okay, you just got this. Then we do the same. So come here, we select, let's just first select the face of the screw. So it's this one. This face, we click mate. Then we select this face and we click concentric. Okay, it's fine. Bring this here. Should be here. Let's bring it here. Okay. So yeah, I need to fix this because these things are moving too much. So I'll do it right now. Okay, let's put mate here. Select this face. We select this face. These ones can be concentric, it doesn't matter. Sorry, coincident. Now we want to fix this piece. So let's go to this face, click here, and here there's a list of all the parts we have. So we see the support one here. We click here in the arrow, and here we have like the planes that where this component is created. So for example, we want to fix this plane, the alzado plane. We just click it, and you can see it's selected. And we want to fix it with the alzado of this assembly. So we click it again, and you see it's now constant. But this one, it moved because we didn't fix it. So you click OK. And now you have fixed this to this plane. Let's bring this back to this plane. Okay, let's just move it. What we can do is, okay, we can fix it. Okay, let's select another face. My computer has some problems. Okay, let's make this. So we're gonna make first we're gonna measure. Oops, let's just minimize this part. So let's first measure the distance from here to here. You'll see why. So let's go to evaluate and measure, and you click here, this face, and then you click this part. Okay, and then you can see we have a normal distance of 270. Okay. So now let's say that we want this bolt to have a range of movement, like having 10 millimeters from here at the limit and 10 millimeters here at the limit. So you'll see how we can do that. So we go to assembly, we click mate, then you select this one, this face, you select this face. Now you see the nut is around here, and then you go to advanced mates and you select in advanced mates, remember, select this distance, and now you can select a minimum value and a maximum value. So minimum value from here to the nut, we can put 10, and from this side, the distance from here to here was 170, and the nut width is 7, since we want a distance from 10 millimeters from here to the nut. So it's 10 plus 7. It will be the thing we need to subtract from the whole distance. So it's 253, because 253 plus 17 is 217. So we choose 253 here. And you click OK. So we have this bolt already here, so we need to check what happened. So it's basically, I think we needed to flip the distance. So we click here and we say yes, we need to flip the distance. So you click edit feature, and here in advanced mates we just click here in flip dimension. So now we have it from here to here instead of from here to here. So we just click OK. Now we click OK. Now it should move from here to here correctly. We still need to fix this because it's kind of annoying that it's moving. So we already fixed this. So now we need to fix. We can fix this plane. So we go to mate and go to assembly. We select this piece, like the support number 1, and we select this plane, planta. You see it, planta. Now we go to the planta of this whole assembly and we select OK. Now we set it coincident with the planta. Set OK, and it's fine. Now we should restrict some of this movement, but it's still moving because we just defined 2 planes. This one, but we haven't defined this one. So what we need to do is the same. Go to mate, then look for the piece, support 1, and now for the vista lateral, you click it, it will appear here. You go to vista lateral of the whole assembly, you click OK, and it's coincident. OK. OK. I'm gonna save this just in case. And now, if I move the nut, this shouldn't move. Okay. But now, okay. Now we have this fixed, and the other thing I think I didn't fix is these 2 planes. So let's just mate it so this support doesn't move. Let's just get this away, and we select this plane, and we select this plane, and we select coincident. So they are in the same. This is just so this support doesn't rotates, you know. Okay, now we have this screw, we have a nut, but now this nut doesn't really like behaves like a nut in this screw. So we need to put another mate so it can behave like that. So we click mate and we select from these options, we select mechanical mates. And we select from this option in mechanical mates, we select screw. And here, next step, you need to select the two faces. You select the face of this screw and you select the edge of this nut, this edge, not the face, the edge. You select it, so you say face 1 from screw 1 and edge 1 from nut 1. Now here you select distance per revolution and we need to put 4, the same as we did for our screw when we created it. Now we put 4, you click OK and OK. Now if you move your nut, you will see how the screw rotates from the nut. You see? And if you rotate, if you grab the screw, you can see how the nut rotates. You can see it difficultly because computer is a little bit slow and it changes like that, but you see. But okay, now imagine we have a motor here. If we want it like rotating, this will also rotate this this nut, and we don't want it. We want it to be like static, like this, and move like have a linear motor, linear motion. So right now, what we need to do is to find a way to fix this nut in this place. So when we rotate this screw, this can have a linear motion like that. So let's modify it and create some guides here. So we're gonna modify our support here. First, save this, please. Rebuild and save document. It's fine. Now minimize this. Minimize it for now, and let's look for our support, which is this one. Okay, we're gonna modify it by adding 2 more holes here, so we can put some guides on it. Okay, so we click here sketch. Then we are going to create some circles around here. Diameter of the circle will be 14. 14 millimeters. We're gonna select distance from the center of the circle to the center. We're gonna select 35. And right now, to finally fix it, we're gonna select this point and the center, and we're gonna choose horizontal. Okay. Now we're gonna create the hole. You click here in extrude cut, and you select through all, and you click OK. Now we have this hole. We want now to have another hole like the mirror here. So to do that, you go to linear pattern and click in this arrow. Then click in mirror, and here it wants us to tell it which is the axis or the mirror face. So we go here at this part. Then you find the plane you can use as the mirror, which is this one in my case. And then it asks you what are the features you want to mirror. So you click this hole, and voila, you have this hole here and the mirror. Oops. Okay, so now you have your support. You click File, click Save, And now if you go to your assembly, now you're gonna see that your supports are like updated automatically. So it's a good function of SolidWorks. So now we're gonna create some guides that we're gonna put here. So for this case, we haven't created any guides, so we're gonna click new, then part. We're gonna create an alzado. We're gonna click sketch. Put a circle here. Smart dimension. 14. Then features, extrude boss base. And you're gonna select 300. And you're gonna flip it right here to the other way. And you click OK. In this case, it doesn't matter if you flip it or not. It's fine. So now you have your guides. So you save it. And you put a name. Got it. Then you go to your assembly. And then you put insert component. And you select guide. Right here. So now you want its center from here to here. So let's use mate and click this surface and this surface. You click OK. Then you want it a little bit. You want it to start from here. So you select this face and you select this other face. And you click coincidence, fine. And you click OK. Now you have this mate. Since this is already fixed, it's just fine. You don't need to put another one here. But what you want to do is to create because this is not really fixed, it can rotate. So to fix it, we're gonna do is click mate. Then we're gonna look for our part here, like before. We're gonna take this away, and we're gonna choose guide, and we're gonna select the plane that we want to fix. Let's say we want to fix this plane. Now you see vista lateral, guide 1, and you want it to be parallel to this one. So you select it, now you see it becomes parallel, and you click OK. And you click OK, and now you have your guide fixed. Now you want to duplicate it from here to here. To do it the fast way, you're gonna click here, linear component pattern, click this arrow, then you click mirror components. Now you need to specify a mirror plane, so we do it as before. Let's say we want a plane from this part, like from the using the support part. So we go to this support part, we click this arrow, and we select the plane that can work for us as a mirror, which is in this case vista lateral, and we select it. And now we select the components mirror, and we select this component. You see, guide 1, and we click OK. Now we have the other one here, and it has the same relations as the other one. Okay, you see, it's fixed. Now we have these guides, but what we're missing right now is that here the nut is not big enough for the guide, so we need to modify this. Let's just click save here. Reveal save document. It's okay. Then let's go look for our nut, which is this one. So you can make it bigger. You can change planes. So now we need to make this bigger. Like it's good if we don't like erase it, so it keeps up like the relationship we already have. So we click here and we click sketch, and then we put a rectangle here. We start building it. So choose some dimensions. We can choose 120 here and 14 right here. Okay, and we click OK. Now, since we don't want to mess with this, we can't just like extrude like that. So for that, we need to click this, and we click Convert Entities to create a sketch from it. Now we have this an hexagonal sketch from this. Okay. Now we can extrude. So we click Features, Extrude Boss/Base. Then it wants to create an extrusion here, and it's like kind of big. So you just put like 7 millimeters. But you see the direction is to this way. So we can click this arrow to make it to reverse it, and we click OK. So now we have this rectangle around here with the same hole. No? Now we want to create the holes for the guides. So let's move to this face and start drawing. Okay, start drawing circles here. Smart dimension. The guides are 14 in diameter. We have a distance of 35 from the origin. And they are horizontal. Okay, we click OK. Then go to Features, Extrude Cut. Then go through all. Okay. Now we do the same as before. We want to copy from here to here. Let's do this. So here we use linear pattern. We click here at the arrow. We use mirror. We select the mirror face, which in this case is this part. This is our mirror face. Features to mirror. We select this one. And that's all. Okay. Now we have our, which was a knot, it's now a rectangle that can support like the guides here. So in the case, like in reality, you will have like the knot glued to this kind of rectangle. Okay, so you click File and Save. Now you get back to your assembly, and you see it right here. Since we didn't specify it before, like this kind of position, so we need to go to Mate. Then we select this face, and we select this face, and we click Concentric. Okay. Now we want to select this face, but it's kind of hard to really like select it if we have this guide. So what we do is that we are in Mate, we right click here, and so it works by selecting Select Others. Will allow you to select these faces, like we'll make this transparent. So you click this, and then you click this guy, and you click OK. Those were already fully defined, but this is making my type. Let's see. Apparently, it was already defined here. So let's just try to keep it here. If I try to move it, yeah, this was already defined. Okay, it's good. Because yeah, we defined this and we defined this, the concentric. So there was no point to do it like this. Okay, but you know, if you have something hidden, you can just right click, put select other, and and you can now select the hidden faces. So now we have this, and as you can see, these guides serve like to stop it from rotating. So for example, if we want to rotate this screw, we now are able to create a linear motion. SolidWorks has a very cool option called the motion study, which basically allows you to put a motor there or simulate a motor there. So let's do this. You click here, motion study, and then you click here. It says motor. Moves the component as if acted upon by a motor. You click it, then you select the face where the motor will be. You click this one, and here's like the direction of the movement. In this case, let's put it from there. If we click this part, we reverse the motion of the motor. We reverse it, and you click OK. Here. Now let's get a little bit farther. Let's just put it right here. Okay, so we can see it more clearly. Okay, so there's a motor here, and basically it puts you a simulation. It puts you some time here. So to activate the simulation, you need to calculate. Click this button, and now it will simulate the movement of the motor, and you can see how this linear actuator actually works thanks to these guides. If we want to see more time, you can select, for example, 15. You just drag this diamond and you select calculate. Now you can see it moving. You see? So if you want to go back, you click model and you get back here. As you can see, this is a very interesting type of mechanism, and it can really help you a lot in your robot. For example, you can use this type of mechanism with a stepper motor to move the extruder, or to implement it into the extruder itself to act upon the syringe. For example, you can put some stuff here, something that put pressure on the syringe. Okay, so that's all for today. Please save this file and send it to me. You can just like well, save the motion study. Like you create this motion study and just click like save animation, and just put like movement or whatever you want, and click save. And okay, make sure results are out there. You want to calculate? Yes. Okay. Now it's saving this video, the movement of the piece. It will take a while, but please save this video and send it to me. I'm still reviewing your homework, so your next homework will be for Thursday, and as I said before in the last homework, will be mainly like to discuss with your whole team, with the big team, about all your findings in your last homework, and to decide which type of robot are you building, and creating a sketch of it. Like this type of design you will use for your partial exam, but for the next homework, I will need like some details from this robot, so I can give you some feedback, so you can improve it for your partial exam. I will give you more details this weekend. I will review all your homeworks and give you feedback. Okay, so that's all for today. Thank you.